Okay, we're going to go ahead and continue on from our previous video with the diagram and the project that was created. The topics that we covered that we haven't covered yet are interfaces, dynamic binding, abstract classes, and secure programming. We're going to go ahead and start with abstract classes and interfaces because they share a lot of the same things. In fact, they are the same. So an abstract class and an interface are the same idea, essentially. And here's the reason. There's a reason why we have interfaces. Well, why do we have interfaces? Why? If abstract classes and interfaces are the same, why do we even have them? But let's just start with understanding what an abstract class is. An abstract class is like a contract. You set up an animal class and you say, hey, I have an animal class, but this class, requires that you render your animal. So say we're creating a game, and we want to treat all animals the same, and we want to call animal render to draw the animal at the animal level, but we want it to draw as a tiger or a cow. And so that whole behavior of that whole need is the idea for abstract classes, is the fact that we can treat them as animals, but have them have that, at that level, create that contract where if you decide that you want a super tiger, that you create a super tiger down here, you have to implement the eat function, or you have to implement the render function, because you got to tell it how to draw a super tiger, because that tiger is going to be drawn at the tiger level, but then you're going to have something that says, hey, the super tiger has extra large fangs or something, and then you draw those fangs in addition to the tiger being drawn, in addition to the mammal being drawn, which is then declared as a contract, a render contract, that you have to have the animals render, so that you can go here in your code and say, hey, Simba, or hey, animal array, let's tell you every animal. Let's do it through a loop even, so that we have a loop that goes for I to all animals, and I'm doing pseudocode here, to all count of animals. So I is just a number, and all those animals I want to render. I want to draw on the screen, or I want them to eat. And then what will happen is all those animals will render as they should, but that only works through what we call dynamic binding. So abstract classes, the reason for them is to implement that contract, where if you build that base class, I can then come in and treat them all as animals at a specific level in my code, and have them behave differently on their own. It's like just setting up this whole thing that just does its own and follows its own rules, and that's the whole idea of abstract classes, that set up that contract, and have the dynamic binding, which is bottom up binding, and we'll get into that more in a little bit. Abstract classes and interfaces are the same, and the reason being is because of the mechanism of the binding. If we go to regular top-down binding, it is not possible to have like an animal go to let's see, okay, here we go. An animal go to, let's see, a mammal to inherit from an animal, and then a tiger to inherit from mammal, a cow to inherit from mammal, but then have a cowish tiger inherit from that. And then once we start this prong right here, this double inheritance, that sets up a nightmare of epic proportions. So you can have a separating inheritance down different chains. You can have chained inheritance. You can do it like that. But you cannot have inheritance from one thing and a whole nother thing into one item. You can't have one item inherit from two different traits. And that's because the binding can only go from one to the next. The binding, when you go from animal when you go and run the eat function for animal, then the binding goes to the eat function for mammal. Then the binding goes to the eat function for tiger, and then it goes to the eat function for the cowish tiger. But we didn't eat like a cow, did we? No, we didn't. And that's because we can't have inheritance. We can't have multiple inheritance. We can't have dual inheritance. We can have chained inheritance, but we can't have where one thing inherits from two items. And that's because of the binding. The binding, when you call those eat functions all together and they work through the logic chain, it can't run two different directions. And that's one of the main reasons why it's not possible. So all an interface is it's an abstract class without the binding. That's it. So all it does is share things like functions. All it shares is a contract that you have, and we use them a lot in a lot of different types of languages for comparison functions, for when we're doing sorting, different types of objects for pre-built sort methods. But yeah, that's all an interface is. It's just the idea of an abstract class, but without the binding. So an interface is the way around the problem of having multiple inheritance. So what we can do here is we can cut the binding of the cow, make the cow just an interface all on its own. And then that interface is not in the chain, the binding chain. And we would just call it something else. We would call it cow traits or cow behaviors or something like that. And it would have a set of functions that would say that a cowish tiger needs to have for it to behave like a cow. So, I mean, it's really kind of stupid, silly, really, these examples I'm showing you. But the idea is the fact that, when we're dealing with an inheritance hierarchy and trying to reduce the amount of code that we write and do things smartly and with purpose, and where things just are so robust that it's just a matter of a few lines of code to make a major change. It's important that we organize things appropriately if we can, and that's where the big boost in software development came in, and all the technology we have is because of those capabilities for rapid application development based on these kind of concepts. So that's why interfaces are used, is so that we can have multiple inheritance and not break the binding chain. All right, so that gets us into abstract classes. I'm not going to go and talk any more about interfaces. Remember, it's just to share a contract set of functions. That's all it is for character or for behavior traits, mostly behaviors, functions. So we're going to get into secure or abstract classes and dynamic binding and why. How is dynamic binding work? What is that what I call reverse or bottom up binding, different from what I call top down binding? Dynamic binding is an actual official term. Top down binding I don't think is. So we're going to get into that as soon as we make our animal class abstract. So let's go ahead and head into some code from our previous time. And what we're going to do is we're going to go and we're going to make our eat function what is called in other languages a contract function or a virtual function. So we're going to go ahead and make one of those functions, and we got to make our animal function abstract first. So let's go ahead and go to our animal function, and I believe we just do the word abstract in front of class. And then we got to declare our eat function as an abstract function. And so what we're going to do is, now that this eat function can no longer have an actual behavior, and that's kind of like the interface is sort of the same. Well, so what we're going to do is, this is going to be kind of like a placeholder. And what this does is it sets up the contract. So the function actually is not implemented in the abstract animal class. It'll be implemented in all of its derived classes. So it's kind of like a blueprint for how animals should be, and then also not only that, but the behaviors of an animal. And then what you can do is you can treat all animals the same in an animal array, but then they all will behave the way they should on their own. It's wonderful how it works. So let's go ahead and implement it, and this is going to be our eat function. That's going to be a true abstract. Other languages call it a true virtual function, and we're going to return. No, it's going to be a void, and then I believe we just leave it empty with a semicolon. And that just declares the contract that everything that inherits from this class, you would do the same thing with an interface, set up a contract function, and then implement it. So now we're going to implement it in the mammal class, and we're going to say the mammal now has two jobs: opens its mouth and looks around for danger. And then what we're going to do is we no longer need to call the super class, because this is now the kind of bottom level of our inheritance hierarchy. And this is just the example. This would be coming with probably a little bit more organization, but this is hey, this is good enough for you guys to understand the whole concepts. Or all the concepts. So now we have mammal class that inherits from animal, fulfilling its contract. And it doesn't like me for some reason. Maybe I did something wrong. Let's see. I think I need a bit of code to them. I think I need to do like override or something here. That's pretty much, and of course, 7 different languages working all the time with. Let me look at my reference material here. I think we just put abstract in front of it. No. You know what, guys? I'm going to be right back. It eludes me for right now, and we just got a little declaration we got to make here, and then we can move on. Okay, yeah, I remembered we got to put the override here, because we're overriding the contracted or abstract classes method. Incidentally, you got to also do that with anything that you override. I believe sometimes you can get away with not doing it with some of the built-in classes. I think so. Yeah, 2-string, I know. But anyways, now that we've got the code in to override this abstract function from our abstract class with our contracted eat function, our mammal now behaves by opening its mouth and looking around for danger. Our tiger calls the mammal portion of the eat. And we may have an issue here. I think we got to do the @ override here too. Okay. Now, what I'm getting ready to demonstrate is called dynamic binding and secure programming. And so this is going to work from the bottom out, not from the top down. And we're going to look at how the behavior of it. First, we're going to look at how it behaves from top down. And what we're going to do is, well, actually, I've already shown you how it behaves from top down. That was in the previous video. So we're setting it up to behave from bottom up. So we're gonna actually have it use dynamic binding when we call this eat function. So I think we've actually implemented it all to make it work. And remember when I said beginning with the end in mind, now that we've overridden and each eat function, we can go back to our main code, and this is working top down. But now what we're going to get into is the bottom up, and that's where this comes in. This is where dynamic binding actually happens. And I think, yeah, I've got a little, new animals, duh, okay. Do I really have to go and look at the example again of arrays? I've already forgotten. I probably have. It's typical. Okay. We're going to then do this. Once I get the code syntax taken care of, we'll get to eating with different cows and tigers and whatnot. So I'm gonna go ahead and get the syntax knocked out, and then you guys can view it, and then what we're going to do is we're going to examine how it behaves and discuss dynamic binding and secure programming and how secure programming works, and why polymorphism, secure programming are all kind of interconnected. So I'll be right back. Okay, so we're back, and I got the rest of the code knocked out, and yeah, I had the public in front of it and stuff like that, but that's okay. So we got now the animal array that we've created, 4 animals, and what we're wanting is the dynamic binding is where we have an array of animals where we're treating them all like animals, but they're also behaving differently. So the first animal is going to be a cow, and the second animal is going to be a tiger, the third animal is going to be a tiger, the fourth animal is going to be a cow. So this is where we're going to implement the dynamic binding. And let's talk about what dynamic binding is, and then we're going to examine the code. And incidentally, we're going to be talking about secure programming too. So dynamic binding is when you, is when instead of going from top-down binding, where you start where the binding, the eat function is called at the tiger level, and then we are then going down at the mammal level, calling the eat function. Here we are taking animals, and we're calling it the animal eat function. This is top-down binding. The tiger's eat function gets called first, then the mammal's eat function gets called from the tiger's function, top-down binding. Then the animal's function gets called from the mammal's function, top-down binding. So when we call that tiger eat, it starts with the tiger eat function. This makes sense because it's the closest function to a tiger is its eat function versus a mammal's eat function. But when we do dynamic binding, we're calling the animal's eat function. So we start with the eat function of the animal, and the animal knows that its eat function is a contract. And it knows on the stack with the dynamic binding, the way it's been built to work, it's like a leap of faith, and we'll kind of get into that in a little bit. But it will then call out to the very last class eat function and know that it's a cow. This animal knows that it's a cow, and to call from the contract to call out to the overridden function to the cow, which then calls the mammal eat function. And that bounce, that dynamic bounce from the base class to the from the superclass to the derived class, is based on kind of a leap of faith on the stack. So whenever you have like the stack, when you have functions being called on the stack, you can think of it as, addresses. So addresses for, like location 700 has a task, and the location 800 has a task. And then, but every time that you have a task, you got to tell it the next location of the next task. So you do the task at location 700, and it says go to location 800 to do that task. And that's kind of how things work with function calling. And with top-down binding, that call in the hex editor, that call when you're doing task at location 700, for that task at location 700 in memory, and you say go to 800, that's all, and then when you do that task on location 800 and you say go to location 900, and then 900 you do the task on location 900 and you say go to location 1000, these tasks, let's say that at location 700 in a program was check serial. And then the program then calls the tasks at location 800. And at location 800, it says, hey, I'm going to check the serial. You pass, go to location 900. Program starts up again. Location 700, check serial. Location 800, oh, you don't pass, go to location 1000. So location 1000 in the tasks of the memory and the function calls means run program. Or no, it means, hey, you didn't pass versus 1 says you pass. So what they can do is they can go into a hex editor and they can say, hey, location 700, and let's get a better table here. And then let's just say 700 is start or check serial. Check. Then it says go to location 800. If you pass, if you don't pass, go to location 1000. Location 800, run program. Location 1000, go back and check serial again, because they're not going to run the program without paying for the serial for things. So at location 700 in memory or in the hex file of your executable, it checks the serial as a task. And if the serial matches, you go to location 800, and that's where you run the program. If it doesn't, it says go to location 1000 and check serial again. And then you go back to location 700 because you don't pass. Back to here. And that's kind of the normal flow of how function calls work in a program. And what you can do is in a hex editor, you can say, hey, location 700, check serial. Let's just take this and make it 800. And you just edit it right in the frickin' hex editor. And now what happens in the program is at location 700, the task to check the serial, it doesn't matter whether you pass or fail because it's set to run the program versus go back and check the serial again because you failed. And that's why top-down programming or top-down binding is a problem. And the way this is fixed is with dynamic binding. It doesn't fix the problem. It actually doesn't, because they've actually found a way around it. But it requires that you run a program along the side, another program that looks and does the change for you dynamically. So it means that you can't sell the exploit to somebody. When you do dynamic binding, it's different. You start with 700, location 700. Hey, check the serial. If it's good, generate the location of the animal that is somewhere out here, or the serial function that needs to be called. So in other words, that 800 location and 1000 location is no longer hardwired into the executable. What it means is now the executable dynamically generates the address for that eat function or that serial, the serial function within the executable itself. So it doesn't have that hard-coded change for function calls when you change one function call to, like run program, call the function to check the serial. You can directly change the flow of an executable by guessing where function calls happen and sending them to a different address. But with dynamic binding, the animal doesn't make that when you compile it. It's all set up so that you can't do that anymore without having another program running aside and looking at that dynamic address that was generated for that next step. And that other programming running aside is just kind of like the idea of having a closed window versus an open window. With top-down binding, that's an open window. Dynamic binding, it's not only the best way of doing things, but it's a closed window of the car. Top-down binding, it's really easy to break these executables and share them. You just break the executable and you can then send the executable to somebody else. Over here, you have to have another program running alongside the executable to guess what that function call will be. And that's all some lower level stuff of that computer science engineering that we won't get into other than how it works and how it behaves. So that's the reason for dynamic binding. Well, not the only reason, but it is a reason for secure programming and polymorphism. So they'll refer to polymorphism as for secure programming. What they're talking about is the dynamic binding. Okay, so let's examine the dynamic binding. And what we're going to do is we're going to skip ahead each of these guys we've created, and we're going to go into where we actually eat. And we're going to see how the behavior of the dynamic binding works. Because we're not calling a tiger eat. We're calling the animal eat. So let's look at that and see how it behaves. Okay, so here we go. Let's do our step into. And I'm going to just sit here and pause on this code for a little bit before we begin. And this will be a good place for you guys to maybe get this code down. So I'm just going to take a little minute pause. Half a minute. 20 seconds. Oh, you can hit the pause button yourself. Never mind. Okay, let's go. Let's do a step into. All right, let's look at this eat function. Okay, so we automatically see that, hey, it calls you're saying, oh, Mr. B, why are we calling the cows eat function? Didn't you tell me that this should start with the animals eat function? Well, it did. You just didn't see it. So what happened is because we are using the animals, we're actually calling the animal eat. we're at that place in scope, but however it knows that it's a cow and it knows that it's overridden to eat. We should probably add our override here. So let's go ahead and look at this, because we may have some. Let's do that. Okay. And we're going to restart, and because I just noticed that, and I've got OCD, and it is what it is. Okay, we're going to have to restart. All right, let's go ahead and run it. Step into again. Okay, so again, this is the dynamic binding, and we're calling the animal eat function. We're not calling a cow or a tiger. We're at the animal scope. And so it knows that it's a cow or a tiger, and it's going to call the appropriate function based on what it is, with the leap of faith of dynamic binding. Okay, so it goes to the cow, and we're going to perform our responsibility. Because it knows we're at the animal scope, but it knows that it's a cow. So yeah, it's not doing top down. You just don't see it. So here is what's happening behind the scenes. Behind the scenes, you've called the animal eat function, and it knows to call that cow. And then now it's your responsibility to call the base class eat function. Which we do here. And we complete the base class eat function. And then we complete the eat function for the first cow. Okay, so I'm going to go ahead and remove the breakpoint and hit continue so we finish this out. I'm going to do some new lines in here so that it doesn't look so ugly. I believe we should do it in tiger and cow. Let's do a \n. That should work. It will. Let's see. And the cow too. Okay. Oh, I don't want to debug, but that's fine. Okay, so now we have two like items: a tiger that opens a cow that opens its mouth and eats grass, and a tiger that opens its mouth and eats meat. They are now working with dynamic binding, and this is secure now, or as secure as it can be without having another program of trying to guess the function location calls within the executable. All right, let's go ahead and get back to where we are pretty much done with talking about interfaces, dynamic binding, abstract classes, and secure programming. I want to recommend looking into research about what the stack is, scope in the stack. Look into dynamic binding, polymorphism and secure programming, and look into how programming hex files work and function calls within a hex file work. Remember, it's just a location with an instruction and then the location of the next instruction, which you can modify with top-down programming or top-down binding implemented within the programming. Or you can go with a more secure version, which is the dynamic binding, which you would have a whole nother, if you wanted to break that, you would have to have another, and they do that, they do break it. You'd have another program running by guessing the location call for the next function. And they could get beyond your serial checks for that way, and get in and use your program. It's done a lot for like 3D editing programs, software, Lightwave, anything that requires a lot of money and you have to edit. You can edit 3D images with and whatnot. So, okay, guys, that's it. Thank you. Bye.